Good morning, students. We have done so far the surface area of two-dimensional and three-dimensional figures. In the two-dimensional figures, we had the square, the rectangle, the circle, the parallelogram, the trapezium, the rhombus. We learned to find out the areas of these two-dimensional figures. I hope you have revised all the formulae. Then we move to three-dimensional figures, the cuboid, the cube and the cylinder. We learn to find out the lateral surface area and curved surface area and the total surface area of these three-dimensional objects. In today's lecture, we will learn to find out the volumes of the three-dimensional objects. Now, what are volumes? So, volumes are basically the amount of space occupied by a three-dimensional object. So volume is the amount of space. Now, like I told you before, everything in the real world is three-dimensional. Yes? So it will occupy some space. The amount of space is occupied is called the volume. So if you are sitting in a room around you, you will observe the room has got a certain volume. Yes, the capacity of the amount of goods can be placed inside the room. The room has got 6 sides, that are the 4 walls, the ceiling and the floor, which is given by the length, the breadth and the height. Now inside this room you will have a cupboard, a bed, a table, a fan. All of these occupy space. So some of them are regular body like the cuboid, the cupboard and the bed are in this shape. You may or may not have a cube in the room. And for cylinders, you will see some water bottles or something which are in the shape of a cylinder. What we are going to do today is learn to find out the volumes of three-dimensional object. So one more time, what is volume? It is the amount of space occupied by a three-dimensional object. So the first we begin with is to understand how do we find volume. Now, for finding the area, we had divided the region into square units. Do you recall what we had done? Suppose we have got a rectangle whose length is say 3 centimeter and breadth is 2 centimeter. So we divide this into we divide the breadth into 2 equal parts, each one of 1 and 1 centimeter, and we divide the 3 into 3 equal parts, each of 1, 1 and 1 centimeter. So we get a square whose length is 1 centimeter and breadth is 1 centimeter. So total the area of this one square is a square of 1 centimeter. So I write 1 square centimeter, also written as centimeter square. Now I find out how many such squares can be enclosed in the space. So I've got 1, 2, 3, 4, 5 and 6. So there are total 6 squares of each centimeter. So I write 6 centimeter square or 6 square centimeter. So to find the area, we had divided the region into square units to find out how many square fits in a particular area. So in the same way, to find the volume of a solid, we need to divide into cubical units. Now what is a cubical unit? A cubical unit, the name suggests, is a cube. But what kind of cube it is? What does a cube have? In a cube, the length, the breadth and the height are all equal. So if you can see in this figure here, let us say this is 1 unit, the breadth is 1 unit, the length is 1 unit and the height is 1 unit. So this cube is occupying a space of how much units? So we say the length is 1 centimeter, say the breadth is 1 centimeter and the height is 1 centimeter. So the total space occupied by this cube is 1 centimeter into 1 centimeter into 1 centimeter or 1 centimeter cube. So now, instead of the square, because this is three-dimensional, we'll look at the cubes. So we'll see how much volume it occupies. Now, if you see in this first figure, this is a cuboid which has been cut into cubes. Now what do you observe here? This cuboid has got 1, 1, 1, 1, 1, 1, 1 and 1. So 1, 2, 3, 4, 5, 6, 7 and 8. The total length here is 8 centimeter. The breadth is only 1, so 1 centimeter, and the height is also 1, so 1 centimeter. So this is a cuboid made up of 8 cubes put in a row. Now in the second figure, this one, you see how they are arranged. 1, 2, 3, 1, 2, 3 and 3 on the back side, 4, 5 and the 6 you cannot see because it is below the 7th one and the 8. You can see these 8 cubes are arranged in the same manner. 1, 2, 3 in the front, 1, 2 and 3 in the front, 4, 5 and 6. 6 you cannot see because it is just below the 7 behind the 3 and the 8. So here there are 8 blocks, cubical blocks, and here also there are 8 cubical blocks but arranged in a different manner. Now here we have 1, 2, 3 blocks, 4, 5, 6, 7 and 8. So these 8 blocks are arranged in a different manner. Then here we have 1, 2, 3, 4, 5, 6, 7 and 8. In here we have got 1, 2, 3, 4, 5, 6, 7 and 8. So all in all there are 8 blocks but they are arranged in many different shapes. Now this shape, the first one, it forms a cuboid. This one is a different shape but you can say it is a larger cuboid. You can say like it is a larger cuboid, the cuboid below made up of 6 blocks and a cuboid on the top made up of 2 blocks. So how it is divided? A cuboid of 6 blocks below and a cuboid of 2 blocks. Here there are 3 cuboids. One cuboid of 3 blocks, another cuboid of 3 blocks and a cuboid in the middle of 2 blocks. Or you can even say a cuboid of 2 blocks on the top, a cuboid of 2 blocks on the top and 4 blocks cuboid below. Here we have got a cuboid in this shape of 5 blocks, then 1 cube below and 2 block cuboid on the top. So all these shapes are different. But what do you observe? That it is made up of 8 cubical blocks. Means all in all the volume of these blocks will be 8 centimeter cube. Though the shapes are different, the volume in each case, the space occupied by 8 blocks will remain 8 centimeter cube. So again, to find the volume we have to divide everything into cubical units. So cubic units are generally used to measure volume. So we measure volume in cubical units. Now 1 cubic centimeter. What is the 1 cubic centimeter means? 1 cubic centimeter means a cube of 1 centimeter whose length is 1 centimeter, breadth is 1 centimeter and height is 1 centimeter. So 1 cubic centimeter is a cube of length 1 centimeter, breadth 1 centimeter and height 1 centimeter. So we got length into breadth into height. So 1 into 1 into 1 is 1 centimeter cube. Means the total space occupied by this cubical block is 1 centimeter cube. Now we know 1 centimeter is 10 mm. So instead of 1 centimeter now I put 10 mm. Again 1 centimeter is 10 mm. 1 centimeter is 10 mm. So 10 into 10 is 100 into 10 is 1000. So I get 1000 millimeter cube. So 1 cubic centimeter is 1000 millimeter cube. Remember this conversion, this will be useful in the sums. Now what about 1 cubic meter? What is 1 cubic meter? 1 cubic meter is a huge cube whose length is 1 meter, breadth is 1 meter and height is 1 meter. A huge cube. Yes? 1 meter breadth, 1 meter length and 1 meter height. So that makes 1 meter cube, because 1 into 1 into 1. 1 meter into 1 meter into 1 meter is 1 meter cube. To convert the meter cube into centimeter cube means how many cubes of 1 centimeter can we put inside the box. That is what we have to check. How many cubes of 1 centimeter can we put in this huge box? So now we'll convert. We know 1 meter is 100 centimeter into 1 meter is 100 centimeter into 1 meter is 100 centimeter. So it is 1 into 1 into 1, that is 1, 2 zeros and 2 4 zeros and 2 6 zeros. So 1, 2, 3, 4, 5, 6. 6 zeros means 10 lakh centimeter cube. So remember, 1 cubic meter is 10 lakh centimeter cube. Means in 1 cube of 1 meter you can put 10 lakh small cubes inside. There will be one row of 100 cubes and 100 below. So totally you got 100 into 100, 10,000 in the first row. In the same way you can arrange 100 of them and total will come to 10 lakh centimeter cube. Now 1 cubic millimeter is a cube whose length is 1 millimeter, breadth is 1 millimeter and height is 1 millimeter. So it is 1 millimeter cube. Now 1 centimeter equal to 10 millimeter multiplied by 10. So 1 millimeter is 0.1 centimeter. 0.1 centimeter means 1 upon 10. So 1 millimeter means 0.1, 0.1. You multiply 1 into 1 into 1, you get 1. But now there is 1, 2 and 3 digits after decimal point. So you will put 0, 0, 3 digits and then you will put a decimal point. So you get 0.001 centimeter cube. So 1 cubic millimeter is 0.001 centimeter cube. This is how the conversions are done. Remember them because we are going to use them in the sums. Now we have got a cuboid here. Okay. So what is this cuboid? Now we'll see how we get the formula. This cuboid, you can see there are 12 units. What does 12 units mean? The length is 12 units. How is the length 12 units? Because there are 12 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. There are 12 blocks of 1 unit kept in a line. So total length becomes 12 units. So I write the length here 12 units. The breadth is having 1, 2 and 3. 3 blocks are placed in a line. So the total length becomes, breadth becomes 3 units. And the height is only 1 cubical block. So the height is 1. So to find the volume, I have to see how many cubical blocks are arranged in this cuboid. So I have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So in total I have got 36 blocks which can be arranged. In the second figure, there are 6 blocks, 1, 2, 3, 4, 5, 6. So there are 6 blocks. So the length is 6 units. The breadth is 1, 2 and 3, 3 units. And this time the height is 2 blocks are arranged one on the other. So the height is 2 units. If you want to count them, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I've got 18 on the top and 18 below. So 18 and 18 makes 36. Okay. One more arrangement. We have arranged 9 in a row. So the length becomes 9 units. We have stacked only 1 in the breadth. So the breadth is now 1 units. And we have put 4 on top of the other. So the height is now 4 units. So how will we count them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Again we have the total blocks are 36. So in each case you can see the volume is the same, the arrangement is different. But now while doing the sums, we will not sit and count again and again. So what formula will we apply to find the volume? How many cubical blocks will take the length, the breadth and the height and multiply them to find the volume. So the formula for volume of a cuboid is V is equal to L into B into H. So if you do 12 into 3 into 1, you get 36. 6 into 3 into 2, you get 36. 9 into 1 into 4, you will get 36. So we can now say that the volume of the cuboid is given by V is equal to L into B into H, where L is the length, B is the breadth and H is the height. So the 36 cubical blocks are arranged in different manners, giving different length, breadth and height, but ultimately the volume occupied by them remains the same. So we have got this formula now. We have derived the formula to find the volume of a cuboid, that is length into breadth into height. Okay. Now one more way this is done is, you can see this is a bit of paper whose length is given L and breadth is given B. So the area of that paper, rectangular sheet of paper, will be length into breadth. Now those papers are stacked one over the other, one over the other, one over the other, such that it becomes a huge pile. Now we measure the height of the pile. The height of the pile is h. So how much space is being occupied now? The area A into the height. So you can say the volume being occupied can be said as area into height. So one way to find out the volume of a cuboid is also area into height, where area A is the base of the cuboid. So we have the first figure whose length is 8 centimeter and breadth is 10 centimeter and height is 2 centimeter. So if you look at this figure, the area of the base A is equal to length into breadth is 8 into 3 or 24 centimeter square. That is shown as the area of the base. Now volume of this cuboid can be found out by length into breadth into height, that is 8 into 3 into 2. But as we have seen, 8 into 3 is 24. So here we can write volume equal to area into height. What is the area we found out? 24. So it is 24 into, here it is 24 into 2. So 24 2s are 48 centimeter cube, and here it is 24 3s are 72 centimeter cube. So in the first figure, we found out the volume by using the formula V equal to L into B into H. That is 8 into 3 into 2. We got 48 centimeter cube. In the second figure, we found out the area. The length and the breadth is not given, but the area of the base is given 24. So here I found out the volume by using the formula area into height, that is 24 into 3 centimeter, 72 centimeter cube. The area of the base is given 24 meter square. Okay, now sorry, there is an error here. What we forgot to do is the conversion. Yes, we have forgotten to do the conversion here. This is 24 meter square. Now since this is in meter square and the height is in centimeter, we have to convert it into meter. So 3 centimeter is 3 upon 100 or 0.03 meter. This will give us 24 into 3 72 and 1 and 2 digits after decimal point. So it is 0.72 meter square. So here you can see the length, the breadth and the height all are in centimeter. So no conversion is needed. But here the area is in meter square and the height is in centimeter. So we have to convert the centimeter into meter or meter into centimeter and then get the volume. So we have to be very careful while dealing with the units. Now from the cuboid we move to the cube. Now like I said, what is the cube? The cube is a figure in which the length, the breadth and the height is equal. So here you can see we have got 2 units as the length. So I'll write 2. The breadth is also 2 units. So 2. and the height is also 2 units. So 2. So count them. You got 1, 2, 3, 4. 4 cubes on the top and 4 below. 5, 6, 7, 8. 4 below. Actually, this is not 7. This is the same one. It is on the back side. We cannot see, but the 4 cubes on the top and 4 below. Total of 8 cubes. So you can just do 2 into 2 into 2, which will also give you 8. But here the length, the breadth and the height all are equal. So volume of the cube can be written as L into L into L or L cube. So here the volume is 8 cubic units. Now I hope you remember this second diagram. In the previous lectures we had done to find out how many sides are painted faces. So I have put this cube here. We'll find the volume of this cube. The length is 1, 2, 3 and 4. So length is 4 units. The breadth is 1, 2, 3 and 4. The breadth is 4 units. The height is 1, 2, 3 and 4. The height is also 4 units. Now, how many total cubes here? So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. 16 on the top row, 16 in the second row, 16 in the third row and 16 in the fourth row. So if you add up all this, you get 64. Also, 4 into 4 into 4 gives us 64. So the only difference between the formula of a cuboid and a cube is the cuboid is L into B into H. The cube is L into L into L. Why? Because the length, the breadth and the height is equal, which is L cube. So volume here is 4 cube or 64 cubic units. So two formula for the day, the volume of the cube and the volume of the cuboid. If you have not understood, you can rewind the video one more time and see through it. We have tried a few sums, let us try a few more. Find the volume of the cube with side 4 cm. So what is given to us? A cube whose side is 4 cm, means length is 4 cm, breadth is 4 cm, height is 4 cm. The formula for the volume of the cube is equal to L cube, that is 4 cube, or write it at 4 into 4 into 4. 4 4s are 16, 16 4s are 64. So 64 centimeter cube or cubic centimeter. Second one is a cube with side 1.5. So cube is again L cube or 1.5 cube. That is 1.5 into 1.5 into 1.5. 1.5 into 1.5 is 2.25 into 1.5. So this will have to multiply 225 into 15. 0, 1 5 za, 1 2 za, 1 2 za, 5 5 za 25, carry 2, 5 2 za 10, carry 2 and 1, 5 2 za 10 and 1 11. So we have got 5 7 3 3. So we have got 3 3 7 5. How many digits have a decimal point? 1, 2 and 3. So we count 1, 2 and 3 and put the point. So the answer is 3.375 meter cube. Because the length, breadth, height is in meter, we get the answer in meter cube. So two very simple formula for the day. I hope you have understood the concept of volume. Volume is the space occupied by a three-dimensional object. To find the volume of a cuboid, we multiply length into breadth into height, or area of the base into the height, and volume of a cube is L cube or L into L into L. Now we'll try a few different type of sums. We have a cuboid here whose volume is given as 275 centimeter cube. Here the volume is mentioned and the base area is 25 centimeter cube. The area is given 25 centimeter cube. So this part, the area of the base, is given to us 25 centimeter cube and the total volume is also given. What we are supposed to find out is the height of the cuboid, h. So which formula will we use here this time? We'll use V equal to area into height. Area goes into division, so volume upon area should be equal to the height. The volume is given 275, area is given 25. So 275 upon 25 should give us the height, right? So we'll do the cutting. 5 5s are 5 5s are 25, 2 remains, 5 5s are 25, 5 1s are 5 11s are. So we have got the height equal to 11. Now we can see here the volume is in centimeter cube. Sorry, the area should be in centimeter square. Yes, in centimeter square. So since they both are in centimeter square and centimeter cube, the height will be 11 centimeter. So very simple sum this was using a formula. But what we used formula, we used volume equal to area into height. But since we have to find out the height, the area which is in multiplication goes into division. So we got volume divided by area gives us the height, and we have got the height 11 centimeter. In this question we have a go down is in the form of a cuboid whose dimensions are 60 meter by 40 meter by 30 meter. So this into is also read as by by. So 60 by 40 by 30. So we can say the length is 60, the breadth is 40 and the height is 30. Now in this huge go down, cuboidal boxes are fit inside. Okay. So we are given the dimensions of the go down. Are we given the dimension of the cuboidal boxes? Let us see. How many cuboidal boxes can be stored in it if the volume of one box is 0.8 meter cube? Now we are not given the dimension of the cuboidal boxes. We are directly given the volume. So volume of one box is 0.8 meter cube, right? The volume of one box. So when you put one box in the go down, it will occupy 0.8 meter cube. If you say put 10 boxes in the go down, then the volume occupied will be 10 into 0.8. What we are doing here is how many boxes we have, we are multiplying the volume of one box by the number of boxes to find out the total volume occupied. So we have to find out how many cuboidal boxes. So we have to find out the number of boxes. So let me say the number of boxes is n. So n into volume of one box, n into volume of one box. Now when I take n boxes of the volume 0.8, it fills up the go down. So number of boxes into volume of one box should be equal to volume of the go down. I hope it is clear to you. You have got a huge go down which has got a very large volume. I can find out the volume. How you can find the volume? Length into breadth into height. So let me find out the volume of the go down is L into B into H, that is 60 into 40 into 30. 6 4s are 24, 24 3s are 72. So volume of the go down is 72,000 meter cube. Okay. Now n into volume of one box. What is volume of one box? 0.8 meter cube. So this shows if I take n boxes and start piling up in the go down will be full. But n number of boxes will occupy this much space. But how much is that boxes? So now we have to rearrange the sum. Since 0.8 is in multiplication here, it should go into division on the right side. So I get 60 into 40 into 30 upon 0.8. Now 0.8 means 8 upon 10. So when this fraction goes into the numerator, it becomes a reciprocal. So we have n equal to 60 into 40 into 30 upon 8. So reciprocal becomes 10 upon 8. So I have got 4 ones are and 4 twos are, so this becomes 10, and 2 ones are, and 2 30s are. So I've got 3 threes are 9, 9 ones are 9, 9 ones are 9, so 9. And how many zeros? 1, 2, 3, 4. So 1, 2, 3, 4. So 90,000 boxes can be fit into the go down whose length is 60 by 40 by 30 and the volume of one box is 0.8 meter. Now you can see what I did here. I've done the multiplication to find the volume of one go down, but in this sum I've kept it as it is. Why I've done that? Because after I multiply huge numbers, and to divide huge numbers is slightly difficult. So I first kept it as it is. I did the cutting, and after the cutting in the end I multiplied, which makes it simpler. So you can try this technique. If you do not want to follow this, you can directly multiply, divide by the volume of the go down. So the choice is yours, which method you want to choose. So these are the different sums we did today using only two formula: length of cuboid equal to length into breadth into height. Sorry, volume of the cuboid equal to length into breadth into height, and volume of the cube is equal to L cube. So for homework, you have to do sum number 1, 3 and 4 of exercise 11.4, which is on page number 191 in your homework book. In the next lecture, we'll discuss the sums and do the next topic. So I'm going to end here. Thank you.